Hello and welcome, everyone. Thank you for joining us today as we announce an exciting new chapter in the world of Tyke. Say hello to Tyke 3.2. We've always believed that great and impactful solutions are often created as a cross between powerful capabilities and an amazing user experience. You need both sides of the equation to work together in harmony for the solution to successfully solve the problem it had set out to address. This is a key endeavor here at Tyke, right from the very beginning when our open source gateway was first launched. And today, you will experience the next iteration of this very endeavor with Tyke 3.2. So, what do we have in store for you? Tyke 3.2 brings with it three very powerful capabilities. First up, we have the Open Policy Agent. This provides the ability to create granular custom permissions with a policy engine that has been baked right into Tyke's API management platform. Next up, we've brought dynamic client registration to Tyke. This gives you the ability to easily integrate with your new or existing enterprise identity providers or IDPs, such as Okta, Gluu, and Keycloak. We've not only made this process simple to set up, but also made it easy to manage on an ongoing basis. And last but not least, with this release, we are launching our next generation GraphQL engine. Apart from turbocharging the already powerful universal data graph, this will also pave the way for subscriptions, federation, and a unique new approach to the system integration problem. So let's dive right in.
We've analyzed our dashboard users and observed that they can wear different hats at moments. For instance, some of them can be like API managers that are interested only about seeing API analytics usage, or we can have like DevOps like APIs, people that can set up upstream connections or configuring server-related options, or API developers that configure the APIs and use them. So at the moment, we have a list of predefined permissions that you can set up when creating users on the dashboard, but we don't think that that is enough. And let me give you a brief example. For instance, let's say you have you are monetizing your APIs, right? And in order to monetize them, you're setting some rate limits or quotas on the APIs. And you have two types of users that can work with that API you created. You can have like an API developer that develops the API and API testers that are testing the API. And through the current permission system, yes, you can create users that cannot touch at all the API section. But what happens when two types of users with different responsibilities are working on the same entity? And the benefit would be to have some more granular role-based access control at the field level or restricting access just for the specific. It's basically a policy engine, a rule engine that lets you define a list of specific rules. And this engine receives some input data that runs them through this list of bottom that the open engine is basically constructed from a list of rules, of policies, and some data, some input. And when your servers, wherever that service is out there, queries this engine, based on the rules and based on the data, it takes a decision and passes it back to the service. And now let's see how this is applied and working on our actual dashboard. When a request is triggered from the client for the dashboard, before hitting the dashboard API, it goes first on the open policy agent layer. It takes as an input the request, all the request data plus the user information and set of permissions. So you have enough information to take some decision, and then runs all this information through the list of rules, and then it's either rejecting them or passing the request further. And moreover, you can enhance that request to passing the dashboard API. And in the end, the request goes back to your client?
Most API management platforms like Tyke offer auth2 servers, fulfilling most use cases. We still do, and we're very proud of it. Yet, when your organization have identity and access management needs, that goes beyond API management, when you need to federate access management across departments, across applications, and you need to manage it centrally under one umbrella, and usually that is under one system, then API management solutions are usually a bit short. Identity access management solutions are very specialized tools. They respond to your specific requirement, whether they are because you need to have very tight control over who has access to what and how they have access it across your different departments, or because you need to respond to an industry standards. The last thing you do is obviously to get a fine from an industry regulator because you do not meet their IAM requirements. So API management is not identity access management. Our dynamic client registration feature enables you to integrate seamlessly with your identity access management tool so that you can have the best of both worlds, really. And it's really important to us that you avoid a fragmented stack. It's a complete integration, not only because it has this no-code setup where in just a few clicks, copy and paste, you are ready to go. And you can also set it at an API level or global level across all your portal. But also because it has end-to-end management. So if you want to revoke access, you can do it. Your API consumer can do it from the portal. Your API product owner could also do it from the dashboard, and your security manager could do it from the identity access management platform.
What are the different identity providers that we are supporting out of the box, and what's the roadmap sort of look like for that?
So as I mentioned, there's so many different ways that you can integrate with your identity access management platform. And there's so many of them that we haven't been able to test all of them. But dynamic client registration is a standard. So if they are following that standard, if your identity provider is in-house built, or if it's specific to your industry and they're following the standards, you can use it. You can use dynamic client registration right now. Now we have tested thoroughly Okta, Gluu, and Keycloak. And in this video you saw it was Gluu, but we are looking at other providers, and we will add them as we go. So if you have a specific requirement and they are not following exactly the protocol, do contact us, and it's fairly easy for us to add now.
Our first version of the Universal Data Graph, UDG, and today we want to talk a bit about where the roadmap is going, what's coming up next. And so when we started developing UDG, we realized that we might not be 100% sure on how should the API definition look like the API to configure Universal Data Graph itself. So we were a bit cautious here. We put a beta label on the dashboard so that people are aware that things might change. And today we're super happy to announce that we're out of the beta phase. So the beta label is now removed, and you can expect from us that from now on we will long-term support the API definition. So if you create universal data graphs using Tyke today, they won't break in the future. All right, so the first thing that we did is to support queries and mutations, because that's obviously the simplest way to get started with GraphQL. And then in the currently released, the 3.2, what we add is now WebSocket support. It doesn't yet mean that we will support subscriptions, not yet. They will come. So as of today, you will be able to use queries and mutations over WebSockets. It's a step forward, but we want to deliver high quality products. So we don't ship too fast if we're not 100% sure that everything is ready yet. But you can expect with the upcoming 4.0 release that we will add subscription support, and that will come with some additional very cool goodies. Like, for example, when we talk about subscriptions in the context of UDG, it doesn't just mean that we support subscriptions for your upstream. So if your upstream is a GraphQL data source, of course, we would support subscriptions in that case. But what we are also looking into is, for example, supporting streaming or PubSub data sources, where you can take Google PubSub or RabbitMQ or Kafka, something like that, turn it into a graphical subscription so that all your APIs become super easy to consume. One thing that we also learned is, so with UDG, what you can do, and I guess most people who already know a bit about UDG, they also know that you can very easily turn REST APIs into graphical with the help of the dashboard, because we have a graphical user interface where you can build all the relationships, and you can write down your custom schema and then wrap existing REST data sources or combine them if you want. And one thing we realize is that there are situations where you want to take some data from one data source that comes as a response, and you want to inject something like a user ID to get the post for a user. In order to accomplish that, what you need to do is construct some construct the URLs to the upstreams in some specific way. We developed a query, no, not a query language, a template syntax. For example, in this screenshot, you can see that we inject the pet ID from the arguments into the URL. And what we learned is that it could be a bit complicated to create these URLs. So Emma from our UX team created this beautiful URL builder, so that now it's super easy for you to build those relationships. You can just select a field from the dropdown to build the template syntax. It's super simple. Another issue that we were facing is that, imagine you have a universal data graph, and it's made up of, let's say, 3 different graphical services. And if something goes wrong in one of these data sources, in one of these upstream graphical services, they don't respond with an HTTP error code, because that's not the way graphical works. Instead, they build a JSON response where they have the field errors. And in this errors field, there can be an array of error messages to tell the API consumer what is going wrong. The problem here is that with UDG, you don't just have like one graphical data source. You could have potentially n data sources, so unlimited number of data sources, if you want to say so. And what we improved with the 3.2 version is that we can now take all the error objects from the upstream responses, and we reconstruct the final response to the client, so that the client fully understands, okay, there's something going wrong in one of my services, and they don't just get like a no op or an empty response and don't really understand what's going on. So with the 3.2, we're now able to forward errors from any graphical upstream. All right. Finally, what we did with switching from beta to like non-beta or production ready, if you want to say so, is that we took some learnings from the initial release, and we rewrote the underlying engine or the execution engine that is part of our open source gateway. So by the way, if you're interested in understanding a bit more on how UDG works, the whole engine, it is open source. It's an open source project with many different contributors. For example, recently we had one guy from Ukraine who helped us improve on one feature related to federation. So it's really amazing to see the community help us build an amazing product, because the community itself, if they want to, they can use the graphical engine that is powering UDG. They can use that in their own project if they want to build something amazing. So a few things changed with the new version of the engine. One is that we increased performance even further, and that is because if you think about the execution of a graphical request, we now split the execution in different phases. So one phase is, for example, the planning phase. So that means if you think about how a server executes a graphical request, what you usually do is, like, first you have a JSON, it contains the request, you pass the JSON, then you have like a query field. This query field contains the actual graphical query. You have to pass the query, you have to validate it, you have to normalize it, like remove white space. Then you have to see, is the user actually allowed to do that? And finally, once you have a validated request, the engine needs to figure out, okay, what kind of request do we have here? What are the data sources we need to fetch data from? How can we construct the final response, etc.? So it's a lot of complicated CPU intensive work that needs to happen. And with the new engine design, we actually split planning and execution into 2 phases. So that means phase 1, you do all the planning, all the complicated stuff, all the preparation. And the key point here is that we are able to cache the execution plan because it's stateless. So that means the heavy execution, or the complex logic validation, all of that, it can happen once, and then you can then reuse this execution plan for subsequent requests. So that makes it super efficient. The second thing is that we implemented a few things to make the second phase extremely fast and very memory efficient. So you can expect super low latency execution times from Universal Data Graph. So if you have a bunch of GraphQL data sources, REST APIs, whatnot, and you have UDG in front of that, you should not expect much latency overhead using UDG. The second change is that we now add, let's say we are ready to add streaming support. So that means with supporting WebSockets, and it kind of lays the foundation that we are now able to add data sources, for example, for MQTT, AMQP, Nets.io. We want to add Kafka, of course. That's something we get asked a lot about. And we want to build kind of adapters or connectors for all those different protocols and data sources, so that if you have, for example, a GraphQL API, you have a REST API, and you have Google PubSub or RabbitMQ, you can just mesh them all together, and then you get this one universal data graph for all your services. So yeah, that's the 3.2 release. I'm super excited for what we're currently working on, which is version 4.0, with some very exciting features. For example, one big cornerstone for the next release is going to be federation, where you can have like a native federation gateway inside the Tyke gateway itself. So that means you can have federated data or federated GraphQL services, like according to the Apollo Federation spec. And you can then take these federated services and combine them with REST APIs or Kafka or SOAP or anything. So as you see, the goal for UDG is just being a super generic engine for you to mesh together all the APIs you have, and then build a super simple, easy to use API for your API consumers, that it's easy to access your data, all together with a full life API management suite. On top of that, like you have the security, you have field-based permission, you have rate limiting, everything out of the box. And this all comes together, helping you to make API management and API integration